This is an acute care facility in Napa, California. It's a hospital extension. It's a renovation. It's a very beautiful building, and my colleague Scott, he's part of the VDC services team, has been working full-time on this project for the last 2.5 years. And his role was to collect data and report back to the owner. What's important to note here is that a CPM schedule has been used to manage the project entirely, and Scott's role on QVMC was to track and make optimization requests to our client, which was the general contractor, so that they could have another level of information. This information was then reported to the owner that was able to derive metrics and make comparisons. But again, I want to reiterate that this was tracked and monitored in both LBMS, but managed using the CPM schedule. So one of the observations that we had during this process, in something that another colleague of mine, Jake Evanger, coined, was ASAP management, or as soon as possible management. And I want to draw everybody's attention to this graphic here in the bottom right-hand corner. What's very clear to note is that we have a very elegant cascading Gantt chart. And I think that any CPM scheduler or any Gantt chart scheduler would agree that that's really what you're aiming to achieve. This is a very simple solution. You can see the cascading effect of the bars, and that's really something that we're aiming to derive. When we look at that right-hand side, you can see the thick planned lines, and we'll go over a little bit more of the mechanics of the LBMS or flow line view. But you can see the thick planned lines, which are reflective of these bars, but you can also see these dotted lines here everywhere, kind of like a bird's nest. And these are the observations that we have gathered from collecting actuals on that project that aren't so visible in that Gantt chart view. And what's most interesting is that as we recorded these actuals, it became very clear to us that we could see those mobilizations, demobilizations, the impacts of waiting time on resources and the costs and the overall impact that it had to their learning curve. Issues like BlowFly effect and flatlining, and ultimately the impact of cascading delays in impacting the final completion of the project. So some of the key benefits of what we're going to learn through looking at this case example of QVMC is understanding what are some of the opportunities for improving production on a project. How the archiving of actual production rates for typical tasks can be leveraged later, as well as the importance of documentation of subcontractor behaviors so that we can make the process better next time and improve our ability to work with those subcontractors in the future. What has our client learned? Really that ASAP deployment adds burden to the construction process. It impacts our ability to forecast work effectively, and most importantly, it impacts our workflow. And we'll start to look at some of those examples of how working out of sequence or completing only so much of a location before moving to the next location makes it very difficult to reintroduce any resemblance of continuous workflow through locations. So this is an example of what we call the BlowFly effect. Now we have here this finishes task, this gray finishes line here running through some of the project locations, and I want to avert our eyes to the actuals of that finishes task. When we follow these actuals, we can see that they get completed to a point where we might have the majority of the crew that we intended to have on site before we man down considerably. And you can see the slowness of that work by that shallow slope before they move to that next location. Then we get some good production, and again we see a suspension in the work before they move to the next location, so on and so on. But really what we're averting ourselves to is that the inconsistency between managing and completing a complete location of work resulted in very much a variable resource demand, indicating a loss of control. These random work patterns and suspended locations impacted our ability to actually complete this project on time. And that's one of the observations that we observed on QVMC. We also observed flatlining, which in hospital construction seems kind of funny. But this was the result of starting in one project location, finishing it 99% of the way, before moving to the next location, finishing it 80% of the way. And you can see how long some of these suspensions were occurring for. We're talking several months at a time for framing walls in this example. Even more months, sometimes in excess of 9 months, completing just 25% of a location. The impact to the resource usage, again, the cost of the demobilization, and trying to manage a subcontractor that has bidded so many hours. It's a circular effect that impacted the overall ability to complete this task on time. What should have been 4 months of work has spanned across nearly an entire year of construction for just the framing of the walls. And again, this is part of that as soon as possible management methodology that we've seen. When the location's ready, when that location's open, let's just do as much work, even if it's only 5%, as opposed to waiting until that whole entire location could be ready for us, and then we can move those resources onto the most appropriate location next to manage that variability, to manage that flow. In this example, we're looking at the electrical resource. And so some of the observations that we can make here, just looking at this bottom flow line view, is that we're starting early in as many locations. And this is often resulting in 2 or 3 or 5% of the work being completed before the location opens up entirely. So early starts having an impact on the overall success of actually closing out an entire location. When we look at this right-hand flow line here, we've used a resource graph indicating the variability of the actual schedule. Manning up to 14 people 1 week, back down to 10, all the way up to 21, back down to 12, back up to 17. Not only is this incredibly high risk, but it's also incredibly high cost, and somebody's got to pay it. So we took a resource histogram. The histogram is our ability to look at past or future behaviors and compare that to what our baseline plan was. So the way that we can read this histogram is if we look at this column here, it refers to the amount of time that was allocated to any one of these bars. And one of these bars represents a week of electrical subcontractor hours. This pink bar was our plan, and this blue turquoise bar was the actual to the left of this red line. So for example, if we look at this last week of May in 2012, we can come across here and we can see that it was just over 300 of actual man hours versus what our plan, which was just over 600 man hours. What is most interesting is if we follow these summary lines across that histogram. This summary line in red here is indicating that we had planned roughly 16,000 man hours for all of that electrical subcontractor work. However, when we look at this turquoise summary line, we can see that we hit just below 26,000. The result of that is nearly $660,000. We used an RS means rate here to calculate this, but if you use actual project cost, this has to be paid out. This money is going to be something that is paid out to these workers that are on site. They're expected to be there. They are there. So we're seeing a lot of downtime. We're seeing a lot of waste in these numbers, which ultimately impacted the bottom line of that subcontractor, the general contractor, and the owner. And so again, we can see that the impact of the BlowFly effect, or flatlining, or demobilizations and remobilizations, all these things come down to dollars and cents, which impact project performance. So why wouldn't we want to try to use a system that allows us to plan for work to be continuous so that we can effectively use crews location to location without impacting the variable and the production rate? In this last slide for the QVMC example, what we're starting to look at here is summary of 3 phases of the interiors work: rough-ins, finishes and trim, and ultimately the commissioning. I want to iterate again that this project was managed using a CPM schedule and not this software. We purely used Schedule Planner and Production Controller as a tool to track the performance of the project per the owner's and the general contractor's request. But when we look at these phases of work, we can see quite clearly that they all started early. These dashed lines here for interiors rough-in started some months early, as much as these dashed lines here for the interiors finished started some months early. When we look at the high level, we can see that the impact on the overall project. It's quite clear that by starting work early as soon as possible, as soon as that location was available, that we ultimately were performing a lot slower because the work wasn't available. And I know that this is something that has been seen on projects before because I've worked on many projects. And we can see the ultimate impact to the commissioning phase here at the end of the project. Unfortunately, in this forecast, we can see that it's pushing beyond that end date. So on QVMC, again, we only used LBMS as a reporting tool. We didn't manage the project that way, but we were really able to understand ASAP deployment. How that really does impact the field management process. How it limits our ability to forecast future behaviors because there's so much active work. All of this active work ultimately impacting any amount of flow, any amount of work being managed or the subcontractor handoffs between locations. Lots of resources working in the same areas, impacting their overall, what we call productivity or consumption rate, therefore impacting their production rate because we're splitting resources across so many of the locations on a project. What we can draw from this is how we can focus on understanding what the opportunities are for improving production down the line. There's a lot of lessons learned here that we can learn from. Using this archive of production data so that we can better manage our next project. And of course, understanding what the behaviors are of using ASAP management as an approach as opposed to trying to use an LBMS or a location-based approach to manage operations during phases of construction.